All right. Good morning this morning, everyone. My name is Anthony, and I'll be taking the mathematics section for today's class. All right. Right here, we have a topic called simultaneous equation. And for us to break down simultaneous equation, we need to understand what an equation is. An equation is a sequence, or let me say, an expression that has to give an assigned value to an unknown value. Now, when we talk about an equation, we have two types of expression that express an equation. We have one to be linear, that is one unknown. And we have the other to be quadratic, having two unknown value in the expression. Examples of a linear equation, here comes a linear equation. Linear equation. Here we have x plus y equals a constant. Here is an example of a linear equation. Also, this linear equation involves two variables. We have x equals a constant. Then here it involves one variable. Also, we have another type of equation in which we use to express our simultaneous equation. It is called a quadratic equation. Now, a quadratic equation is helping us to look for two unknown values that make that expression defined. Now, examples of a quadratic equation, we have quadratic equation. We have x squared plus x, then plus a constant equals a 0. This is having one variable involved. Also, we have another type of quadratic equation where we have x squared, y squared, plus x, plus y, plus the constant equals 0. This one says two variables involved. Now, these variables involved that we're talking about are the unknown values that we need to assign a numeric value to. Now, simultaneous equation involve two expressions coming together. That is, they are meeting at a point. That's when we talk about coordinate geometry. An expression or an equation also represents a straight line. In coordinate geometry, equation represents a straight line. And when two lines meet at a point, it shows that the two lines are solved simultaneously. Let's bring out an expression to show what a simultaneous equation looks like. I have a past question here with me where I'll be hoping to find the first question for the day. And that will help us to know how to do simultaneous equation together. All right. Open with me to page 76 of your past question. I have a question 7 there. And the question 7 there says, solve the following simultaneous equation. Solve the following simultaneous equation. Here we have x plus y equals to 10. Then we have x squared plus y squared equals to 58. Now, looking at this expression, what we have on the board here, we have two expressions that makes an equation. And we want to solve them simultaneously. But solving simultaneously, we need to know the type of expression we have or the equation we have on the board. The first one says x plus y equals to 10. The highest power there is 1. So that means that what? This is a linear equation because the highest power there is 1. The next one says x squared plus y squared equals to 58. The highest power here is 2. That tells you that what? It is a quadratic equation. If, for instance, let me just bring to your notice, we have another equation having x cubed plus y cubed minus 100 equals to 0. Then you know that what? The power here is increased by 1. So the highest power here is 3. So we call this one not a linear, not a quadratic, but a cubic equation. Take note of the difference of the type of equation we have on the board. Here is a linear equation, linear. Here is a quadratic, quadratic. And this man here is called the cubic. We also have other types of equations, but for this class, let's just limit our scope to what? First, second, and third degree of our equation. Now, the question gave us 2 degrees of equation, and we are told to solve simultaneously. That is, look for the unknown value x and y. To solve for the unknown value x and y, first thing you need to do is equate one expression to look as one variable is out. That is, you are making a variable subject of the formula. That is, from equation 1, I call this equation 1, I call this equation 2. From equation 1, we say x plus y equals 10. Then here, subtract y from both sides. It is advisable you take it step by step this way, so you won't make a mistake while solving. Subtract y from both sides. This implies x plus y minus y equals 10 minus y. Then here, when we subtract y from both sides, we are left with x equals 10 minus y. So I can call this one my equation 3. Having solved up to this point here, you should know that what? The value of x here is now having a defined value that has an unknown in it, which is y. So let us substitute the value of x here into the other equation to see if we are right or wrong. Yes, we say what? Substitute the value of x into equation 2. This implies from equation 2, we have x squared plus y squared equals 58. Hence, anywhere we have the value x, we replace with the value of what? 10 minus y. Therefore, we have 10 minus y all squared plus y squared equals 58. If you arrive at this point here, then you are making a progress. So from here, I can bring it up here again by simplifying further. From equation 3, we have 10 minus y all squared, then plus y squared equals 58. Let's open the bracket first. Opening this bracket, we have 10 minus y times 10 minus y squared equals 58. I love it taking it step by step so you can see your progress. At this point here, to expand this bracket, we say 10 times 10, 100. We say 10 times minus y, minus 10y. We have the minus y here times 10. We have minus 10y, then we have minus y here times minus y. The minus and minus omit itself to be what? Positive. Then we have a y squared. Then plus this y squared equals to 58. Now, from here, we can see that what we have common terms. The common terms can be collected, that is, collect like terms. Even both component-wise can be collected together. That is, y squared plus y squared minus 10y minus 10y, then plus 100. Then you bring in 58 to the other side, we have a minus 58 equals 0. This is called equating component-wise. Then from here, equating component-wise, we have 2y squared minus 20y. Then 100 minus 58 should give us the value of 44. So I have plus 44. No, 42, please. Be careful. So we have 2 plus 8, 10, 4 plus 9, that's plus 1, 10. So we have this to be what? Correct. Having this, we have the value of the highest power of y to have its own coefficient of 2. So let's reduce the coefficient of the highest power to 1. That means divide all through. Divide through by the value 2. Divide through by the value 2. Then here we have this to be, this implies 2y squared minus 20y plus 42 equals 0. Everything divided by 2. So I have over 2, over 2. Then I have over 2, over 2. So here I have this to remain y squared minus this to remain 10y. Then this should remain 21. Then this to remain a 0. Are we good to go? If you have a question, you can just signify. In the absence of no question, I can continue. So let me pause a bit and see if you have a question. Anyone with a question? Anyone with a question? I'm going to unmute the mic now so you can speak out. Anyone with a question?
I don't understand why you're dividing all sides by 2.
You don't understand what?
Like, what's the reason?
The reason for?
Dividing all sides by 2. Is it that they have...
Dividing all sides by 2. Thank you very much. The reason for dividing all sides by 2 is because we are going to solve quadratically. Remember, I gave you different types of equation at the beginning of the class. So the first type of equation was a linear equation, having the highest power of 1. The next type of equation was a quadratic equation, having the highest power of 2. And the way you can solve quadratic equation, you solve quadratic equation either by factorizing or by what? Using other formula method. Now, we don't want to use formula method in terms of simultaneous equation, but we do want to factorize. So in order for you to factorize completely, then you have to reduce the highest power of your variable to have a coefficient of 1. Is that clear, class? Is it well clear? Hello. The mic is on mute. I can hear you. Is it well clear, sir?
Yes, sir.
All right. So I can proceed. Now, I take it up here.
So,
yes? You have a question?
Yes.
All right, your question, sir.
You wrote 2y squared minus 20y
yes.
plus 42.
Yes.
And you
plus
divided
42.
by, yes, and you divided
2.
by 2. Yes, that means what you're going to get is y squared minus 10y plus 21.
Then it shows you are with me in class. Kudos to spotting that error. Thank you very much.
Yeah, no problem.
Can I proceed?
Yes.
All right. It shows you are following. Now, bringing my equation back up here. Y squared minus 10y plus 21 equals a 0. Are we good to go? Now we introduce a method in quadratic equation. Now, we have 3 methods in solving quadratic equation. We have the factorization method, we have the completing the square method, and we have the formula method. Now, out of these 3 methods, the simplest of all is the factorization method. But students love going with the formula method because they just love to slot in their values, then get my answer direct. But our advice, you get familiar with factorization method before you can able to what? Use that formula method. Because the hierarchy starts from what? Factorization method. Get familiar with completing the square method. Then it is from the completing the square method, then you can now use your formula method. So for this class, we are making use of what? Factorization method. So I say, factorize completely. Factorize completely. So how do we factorize completely? Y squared minus 10y plus 21 equals 0. You ask yourself 2 questions. What are those 2 numbers that if I multiply the value of y squared and 21, I will get 21y squared, isn't it? Now, what are those 2 numbers that when I multiply them together, they are going to give me the same value of what? 21y squared. And when I add or subtract, they are going to give me the value of minus 10y. That is the two questions you need to ask yourself. I will rephrase the question again. The question is, before you ask the question, multiply the value of 2y squared, that's the y squared, and your constants. Value of the highest power times your constant together. You have a value here. The value is 21y squared. Now here comes your question. What is that two numbers that when I multiply them together, they'll give me 21y squared. When I add or subtract together, they give me minus 10y. That's the first question I'm asking you. Now, to give me my answer, I would point out something here. Those are what? Factors of what? 21y squared. It's an hint for you to give me an answer. The factors of 21y squared says that what? I can have 21. I have 3 times 7, isn't it? Another value multiplied to 21? No other value. So that means 3 times 7, I can have 3y and 7y. If I multiply these two together, they give me what? 21. But if I add these two together, do they give me a minus 10? The mic is on mute now. If I add 3 and 7 together, do I have a minus 10?
No.
No, thank you very much. Now, I have asked a question earlier. Now, I'll ask the question. So you can use the idea of this factor to give me my answer. What are those two numbers? Please consider the sign. What are those two numbers that when you multiply together, they give you a positive 21y squared? And when you add or subtract, they give you a negative 10y. What are those two numbers?
Sir,
Minus
7y and 3y.
Minus
7y.
7y minus 3y. I love that. A good contribution in class.
minus 7y and minus 3y.
Minus 7y and minus 3y. Yes. So we say this implies 1y squared minus 7y minus 3y plus 21 equals a 0. Then from here, we can collect like terms this way. Collecting like terms, we can say, what is that value that is common here that we can factor out here? The mic is on.
Y.
It's common here between y squared and 7y.
Y.
Y, thank you. Open a bracket. So y squared divided by y, we are left with y. 7y divided by y, we are left with 7. Close it. We have a minus here. What is that thing that is common between 3y and 27?
Minus 3.
Minus 3. Thank you. Forgetting the fact that I brought out my minus here already. So you include a minus. I say minus 3. Open a bracket. Minus 3y divided by minus 3. I'm left with what? A y. Then 21 divided by minus 3. I'm left with what? A minus 7. Then we close the bracket equals to 0. Are we good to go, class? The mic is on. Are we good to go?
Yes.
Yes, sir.
Now, connect this y and minus 3 together. We have y minus 3. Then pick one of the y minus 7 that we have here, which is y minus 7. So here we have been able to factorize this man up to 8 times. But to factorize completely, say y minus 3 equals to 0. Or y minus 7 equals to 0. Therefore, the value of y equals what? 3. Or the value of y here equals to what? 7. So we have successfully solved the following simultaneous equation completely. So the value we arrive at as our answer, what will be the value of our y? 3 or 7? Do you think this is the final answer?
No, sir.
No. What are we looking for now?
X.
X. Thank you very much. Having the value of y to be 3 or 7, which of the equation do you think we are going to substitute the value of y into? Is it equation 1, equation 2, or equation 3?
Equation 1.
Equation 1. Why not equation 3?
Sir?
Why not equation 3?
Because
Yes,
equation 1 is Equation 1 is
Because
more simpler.
it's more simpler. But have you
Yes.
forgotten the fact that we make x subject to a formula in equation 3, and that gives us what? 10 minus y. So it is easier that way. What do you think?
Yes, sir.
Do we should go with equation 1 or we go with 3?
Equation 3.
Anyone.
You want 3 now?
Anyone.
Anyone? All
Yes.
right. Please, on the day of
Anyone.
exam, to be strong in your words, answer. Go with your mind. So I'll go with equation 1, like you said, for learning sake. So bringing it up here. Bringing it up here from equation 1. From equation 1, I have x plus y equals 10. Put or substitute the value. Substitute the value of y into equation 1. This implies that when y equals 3, x plus y equals 10. X plus y is 3 equals 10. X equals 10 minus 3. Then the value of my x is 7. Or when my y equals to 7, x plus y equals to 10. X plus 7 equals to 10. X equals 10 minus 7. Then the value of my x is 3. So at this point, we have successfully given our answer to the simultaneous equation. So this is how we write it out. When x is 7, y is 3. So I have 7, 3. Or when x is 3, y is 7. So 3, 7. So you can add this in your option. Then you pick the correct answer. Is that clear, class? Is that clear?
Yes, sir.
Any question before we move on? Any question before we move on? The mic is on. I can hear your feedback. Any question before we move on? Okay. By the end of today's class, I can strongly say that you'll be able to solve simultaneous equation if you follow my solution promptly. Is that clear, class? Okay, let me bring out one more question for you. Then we'll use that to protest our point on simultaneous equation. I have my past question here. I'm opening to page. Okay, page 67. Page 67. Page 67. Page 67, question 6 over there. Question 6 over there. It says, the line y equals to 5x minus 3 and y equals to 2x plus 9. Are we there? Intersects at P. What are the coordinates? What are the coordinates of P? Now, this question comes from coordinate geometry. The question, it arises from coordinate geometry. Now, in mathematics, don't just limit your scope to the topics alone. Yes, because in other topics, you will still find elements of other topics in it. Like the simultaneous equation we are talking about here. You find elements of it in your sequence and series. You find it in your coordinate geometry. You find it sometimes in your permutation and combination. Also, we have other algebras that are also interwoven in other topics. So don't limit your scope to what? Simultaneous equation only. There are some other questions that lead to what? Simultaneous equation. And here is an example. Is that clear, class? Now, having this question, what do? They said they intersect at a point P. So that means the two equations are the same. 5x minus 3y equals 2x plus 9. Equation 1. Equation 2. Now, this is a simultaneous equation. We have different methods also in solving simultaneous equation. We have elimination method. We have substitution method. And we also have, I think, the factorization method also. We also factorize in simultaneous equation. But yeah, in simultaneous equation, the simplest of all is the elimination method. Because you need to make one term equals the other for you to eliminate. Looking at our expression, we have 1y and we have 1y in the other equation. So these 2y looks alike. So I can eliminate y out. So I say subtract equation 2 from equation 1. So I have y minus y gives me 0. I'm left with 5x minus 2x give me 3x. Then here we have minus 3 minus plus 9 becomes minus 3 minus 9. And that gives me what? Minus 12. So here, everything here equals 0. From here, this implies that 3x here equals 12. I divide both sides by 3. Then the value of my x equals to 4. Now, since the value of my x equals to 4, I say substitute the value x equals 4 into equation 1 or 2. So I go with equation 1. So this implies that y equals to 5x minus 3. Y equals to 5 in brackets, x is 4 minus 3. Y equals to 5 times 4, 20 minus 3. Then the value of my y equals to 17. So what is the coordinate of our point P now? Our point P having the coordinate x, y is given as 4, 17. You can find this in your option. Is it clear, class? The mic is on. I can hear your feedback. Is it well clear? If there's any question you need to ask concerning this shortcut method, please put your question out now. In the absence of no question, so I assume this question is well clear to you. Okay. While you guys are writing out the solution, I would love one of you to present me a question on simultaneous equation. Let's use that as a class drill today. So I'll be waiting for a question from you guys. I believe you have a past question with you over there. The mic is on. Do you have your past question with you?
Yes, sir.
So one of you should give me a question on simultaneous equation. Very quick. That is how we can engage ourselves. So look for a question on that past question, simultaneous equation. Very quick, and let us know. While you are doing that, I will also try to help you out with few of it. Have you found any yet? Have you found any yet? Well, I don't have much time. Let me help you out with a few of mine here.
Yes, I found a question.
Okay, wait, question, call it out.
Okay, 2x plus 5y
2x plus 5y
equals to 11.
11.
Then 7x plus 4y
Plus 4y
is equals to 2.
equals to 2.
Yes,
So
solve
we
the
have to solve simultaneously.
Yes.
All right. So here is a question for us to what? Solve. So we say solve simultaneously. Solve simultaneously. 2x plus 5y equals 11. 7x plus 4y equals 2. Class, we have two types of method I want to introduce here. Elimination method or factorization method. Choose one.
Elimination method.
Or factorization method. Choose one.
Elimination method.
Elimination method. Now, follow the steps promptly so that we can finish it on time. The first thing you need to do is what? Make one of the variable equal. So we go with the variable x. Multiply both sides by, multiply the first one, equation 1, equation 2. Multiply equation 1 by 7 and multiply equation 2 by 2. So yeah, this implies 7 times this, 14x. 7 times 5, 35y. 7 times 11, 77, equation 3. 2 times 7, 14x, plus 2 times 4, 8y, equals to 2 times 2, 4. That is equation 4. This we have x equal. So we do what? Subtract both sides. When you subtract both sides, 14 minus 14 is what? A 0. 35 minus 8, what do we have? 827, isn't it? Yes, 827y equals to 77 minus 4. That is giving us a 73. Are we good to go? Sorry, it's 73, correct? It's 73. So here we say the value of y now equals divide both sides by what? 27. So finally, y equals to 73 over 27. Yes, that is the right answer. Because looking at the expression, you can have a whole number as your answer. Are we good to go? The next one we say substitute. Substitute the value of y into equation. I go with equation 2. So here we have equation 2 says 7x plus 4y equals 2. Then here we have 7 in bracket of what? 73 over 27 plus 4y equals 2. The 7 here can take away. No, 7 can take away. I can say multiply all through. 7 times 27, 73 is 21, 49. That's 511 over 27 plus 4y equals 2. Then from here, I can say that collecting like terms, I have 4y equals to 2 minus 511 over 27. First, confirm 23. Yes?
So you substituted for x instead of y.
We have solved for x. Oh,
Y
thank you very much. Thank you very much. So we are looking for y now. Thank you very much. So I have 7x plus 4 in brackets. That's 73 over 27. So I have 7x plus 4 times this. 12, 28. So I have 29. 292 over 27 equals to 2. Then here we have this one, 7y. So 7x now equals to 2 minus 292 over 27. So I have it to be what? LCM is what? 27. I have 27 times 2 is what? 54 minus 292. So finally, I have 7x here to give me a negative value. A negative value. What is the value of 54 minus 292? 12, 8, 8, 3, 238 minus 238 over 27. Then the value of my x now say minus 238 over 27 times 1 over 7. So final answer is minus 238 over 27 times 7. That's giving us what? 49, 14. That's 189. So this is the final answer for x and y. Confirm that for me using your calculator and let me know your answer against the next class. Is that clear, class? So we've come to the end of the class today. If there's any question you want to ask, please put down your question in your notes. Against the next class, present your question for me before we start the next section. I leave you to enjoy the rest of today. Au revoir.